Okay, so when we talk about circumference, arc length, and areas of circles and sectors, we always want to remember that these things, the arc length and sectors in particular, are portions of the entire circle. The entire circle has 360 degrees, and so we would figure out what the central angle is, divide by 360, and then multiply by either the area formula for a circle, which is pi r squared, or the area for the circumference of a circle, which is 2 pi r, or pi times the diameter. There are a few theorems that we need to know. The central angle is equal to the intercepted arc. So you look here and you see that the measure of angle AOB is equal to its intercepted arc, which is 80 degrees. So the measure of angle AOB is equal to 80 degrees. We have an inscribed angle. That's where you draw it back to angle or to point B. And in that case, angle X is equal to 1/2 of the intercepted arc, so that would be 50. And then we have the tangent and chord angle theorem, and it is equal to 1/2 of the intercepted arc. So in this case, the measure of angle ABC would be equal to 60. And I do believe that that is what we needed to know on that one problem that we were working on Friday. And then for our first sample question, we have the embroidery design problem, which I know we've done before, but I'll do it again. There are 4 semicircles or 2 circles, and there are 4 quarter circles or 1 total circle. So a total of 3 circles, and they are all congruent. And they each have a 2.5 inch diameter, which means that they have a 1 1/4 radius. Or if we turn that into a mixed fraction, it would be 5/4 radius in inches. Now we need to figure out what that is in terms of the perimeter. The perimeter has to do with the circumference. So the circumference is equal to 2 pi r, which in thinking backwards, I didn't need to change it to radius. So that would be equal to 2 pi times 5/4. And when I multiply that all out, I get a circumference equal to 7.85. That's the circumference of one circle. The way that I found that was by doing 2 times 3.14 times 5, and then I divided that quantity by 4. Got 7.85, but I know that there are 3 of them, as we discussed earlier, so I will multiply that answer by 3. So I get the circumference equal to 23.55, but the question says to the nearest whole inch, so that would be C equal to 24. And so my choice is answer C. Okay, for sample question number 2, we are going to look at intercepted arcs, and remember those are half of the angle is half of the intercepted arc, and so the measure of arc ADC is equal to 255. That would leave 360 degrees minus 255 for 105 degrees for arc ABC. And then since that is the intercepted arc of this angle, that's going to be divided by 2 for 52.5 degrees. And that's our answer. For the equation of a circle, you are mostly going to be working in this section where the center is at HK. This is the one we've talked about the most. And it works actually for the center who's at the origin. And the origin, as we know, is 0, 0. That would make H and K 0, 0, so it works either way, the formula. You have to remember that you're going to change whatever the coordinates of the center are. You're going to change them when you put them into the equation. Whatever the radius is, you're going to square it when you put it into the equation. On the other hand, if you're given the equation and asked what the radius is, you're going to square root it. So just keep that in mind. Our first sample question, and I think the only one in this section, is about a radius of 5. And so they're asking us which equation has a radius of 5. And so we can eliminate answer choice A and answer choice C because you have to square that to put it in the equation. And then we have a center of 3.7 and -2, and remember you have to do the opposite when you put it into the equation. So it's going to be -3.7 and +2. So our answer choice that we want is choice D. Next, we're going to look at polyhedra. That was our very first unit when we started in August, and I want you to remember these special names and how many sides or faces that they have, because that's going to help you answer questions on the exam. If you want to, you can also remember the edges and vertices. If you memorize them, it'll make it a quick question for you to answer. However, I think you can probably visualize most of them. As you get higher, it'll be tougher, but that's just my opinion. In sample question 1, we have a net of a polyhedron, and the question is how many edges does it have? And so you have to imagine folding that piece up. And I think we actually did this at the beginning of the year where we cut those out and we folded, I know we did, folded them up and made them into little three-dimensional shapes, and you'd have to figure out how many edges it has. So it's tough for me to just say that this is what it is, but you might be able to think about it, visualize it, and come up with a solution. You might also notice that this is a triangular faced object, and so the only choices that we have for those are the tetrahedron, which is going to be like a pyramid shape, or the octahedron. And you can see that there are 1, 2, 3, 4, 5, 6, 7, 8 faces in that. And so that's going to definitely put us in the octahedron category. So we look at the choices, and so our selection would be in terms of the edges, it would have 12 edges, the octahedron does, and so our answer choice is C. Question number 2 is really just a vocabulary question. How many faces does a dodecahedron have? And the dodeca means 2 plus 10 dodeca, so that would be 12.